Alright, ladies and gentlemen, we're going to do Exponents Part 4. Now, once again, got to be a good student. Take notes. Pause the video to write questions. When you answer those questions, you need to re-pause the video. Go back, write your answers to your questions because those notes are letters to future you. Things that you figured out today that you might forget. You might want to remind yourself of. So why go through all that hard work more than once? And again, sometimes you need to see something multiple times. So sometimes just watching it once isn't enough. You need to do it again. Read your notes. Re-watch the video, try the practice problems, all that kind of stuff. I'll shut up now. Let's get into it. Here's what we're going to be doing today. Exponents Part 4. So in Exponents Part 4, we're going to get into why negative exponents are division. And we're also going to see why anything to the power of 0 is equal to 1. All right. So now let's go ahead and dive into that. So let's start with a to the fourth. Would you guys agree that this would be 1 times A times A times A times A? Would you guys agree with that? Yeah, I would, right? Exponents repeated multiplication. We don't ever really need to write the 1, but we're going to write it right now, and you'll see why in just a second. Would you guys agree then that A to the third would be the same as 1 times A times A times A? Would you guys agree with that? Now, based on what you know from before, if I said that, would you guys agree that that would be A to the third? Right? Because you're going to, bases are the same, you add those exponents. Or, what if I said this? 1 over A. Would that be the same also? Yeah, absolutely. Do you see? And that would be A to the third as well, because we're taking this whole thing and we're dividing it by A, and those would reduce. Do you see? So what if we did the same thing here? What if we did A to the third times A to the negative 1? And wouldn't that give us A squared? And A squared would be 1 times A times A. So each time we divide by the base, we end up with 1 less. So if I took A squared and I divided by the base, that's division of A, that would be just A. Would you guys agree? So A to the fourth is 4 A's, A to the third is 3 A's, all multiplying. A squared is A times A. A to the power of 1 is just A, 1 times A. You never need to write the 1, but check this out. If I had A to the 1 and I multiply it by A to the negative 1, wouldn't that be A? That's this A, divided by A? Wouldn't that be A times 1 over A, which is that? Doesn't that equal 1? Do you see? Just 1. And that works for any number, 7, 42, whatever you want, anything but 0. Now, what if I took 1 and I multiplied by A to the negative 1? Wouldn't that give me 1 divided by A? Do you see? And I could do the same thing again. What if I took A to the negative 1 and I multiplied by A to the negative 1? Because that's what I'm doing each time. You see, I'm doing times A to the negative 1. Whatever I started with, times A to the negative 1. Well, wouldn't this give me A to the negative 2, which is 1 over A squared? A base is the same. You add the exponents. Negative 1 plus negative 1 is negative 2, right? And this means division. It means 1 divided by A squared, which is this. So A to the negative 2, A to the negative 3, do you see? That's how it works. Exponents are repeated multiplication. Negative means opposite, so a negative exponent is repeated division. The tricky part is division is multiplication by the reciprocal. That's why you flip it over. The reason the sign changes is because you took care of that division. You rewrote it as division. Just like if you did 10 divided by 5. That's the same as 10 times 1/5. Where did the division sign go? Well, you rewrote it as multiplication by the reciprocal. That would be the same as this. Do you see? Exactly the same. So, got that under our belt. Now, let's talk about doing some ugly problems here, shall we? Let's say we had this. That's a Z. Let's say we had that right there. Now, what I want to show you is why this is equal to I want to show you why those are equal. Here's what we're going to do. Check this out. When you see something like this, what you're going to do is you're going to attack this as if it's three separate problems. You're going to take the x's, you're going to look at them together, you're going to look at the y's together, and you're going to look at the z's together. You can do it all at once, or you could separate it like this. Do you see? And then looking at the y's, this is what we got. Looking at the z's, this is what we have. Would you agree that this one right here is the same as, right? Oh man, that's a really ugly one. Here's the shortcut. Like the shortcut is, when you're dividing, you do multiplication by the reciprocal. So the reciprocal turns everything over. This is fine. It stays just like it is, but you have to do the reciprocal of that. So that means that it's going to move to the top. So what you're going to have is you're going to have x cubed times x squared, which is x to the fifth. That's where that comes from right there. So when you do, so for example, let's say we did a to the third divided by a to the negative 4. Oh man, that's going to be a to the seventh. Whereas if you had a to the third divided by a to the fourth, that would be 1 over a. Do you see? Whereas if you had a to the negative 3, a to the 4, that would be 1 over a to the seventh. Do you see how all that works right there? If you have a negative exponent, look at these. We got 3 different examples right here. These first two that I put in a little kind of boxes, they have negative exponents. The thing with a positive exponent stays wherever it is. If it's in the numerator, it stays in the numerator. If it's in the denominator, it stays in the denominator. But anything with a negative exponent needs to be rewritten as division. That's why this thing right here means that it's going to go down there. So if I had 4 down there and now I have 3 more, that makes 7. Whereas this one, this negative 4, means it's going to go to the top because you do the reciprocal, multiplication by the reciprocal. Well, if I have 3 a's there multiplying, now I have 4 more, that makes 7. Do you see? That's how it works. And this one's just plain old reducing. I have 3 on the top, 4 on the bottom. That means I have 1 more on the bottom than I do on the top. See? 1 more on the bottom because there's 4. There's 3 on the top, 4 on the bottom. That's 1 more on the bottom. That's why it's like that. A to the 1. You never need to even write that a. Do you see? So let's apply those ideas here. Do you see? This y has an exponent of 1. This one has a negative 5. That means the negative 5 is going to go to the bottom. Oh, and it makes a 6. Oh yeah, you see how that works right there? Oh man, I wonder if who's calling me here is like, oh, I bet it's, I'm not even going to waste your time. I bet it was car insurance or something. So look, I messed that one up right there. That's a to the, or y to the 6th. I messed it up totally. You see, I have 5 and then 1, that makes 6. Do you see? Did you catch that? Hey, if you caught my mistake before I did, I want you to leave me a comment. Oh man, I'd like to hear from you. See if you got that one. Now this one is correct. That's 7 y's on the top, 3 on the bottom. That makes 4 on the top. Whereas if it, or sorry, z's. Whereas if it was this way, you see there's 3 on the top, 7 on the bottom. That makes 4 more on the bottom, and it reduces to just 1. Because this would be 3 z's, and then 7 z's would be 3 z's plus 4 more, right? So those all reduce to make just 1. You're left with 1 over z to the 4th. Let's do one more example, shall we? Let's do one more example. Let's say we had some big, big, ugly thing. Let's do 2 more examples. I lied to you. Let's say we had some big, ugly thing. X, let's say 3x to the 14th, y to the 6th, z to the b over ax to the negative 1, y to the 141, z to the negative c to the power of 0. It's just 1, bruh. This is the base to the power of 0, just equals 1. Easy. So don't get fooled. Anytime you see something to the power of 0, it's just 1. Now, what if it had a 5 over here? Oh, then it would be 1 times 5, which is just plain old 5, of course. Do you see? Okay. What if we did, though, have something like, let's say we had 3 to the negative 2, a to the 4th, divided by 3 to the negative 4th, a to the negative 5th. Try it. Try it. Now, before you do, though, separate that. Separate that into the 3's and the a's. Look at them separately, like 2 separate problems. Go ahead and pause it and try it. All right, now check this out. Here's what this is going to be. I'm going to do it in my head and try not to mess up like I did the last time. Do you see this 4? This 3 to the 4th? That's division. It's in the denominator, so that means it's going to go to the numerator. So that would be like this. This 3 squared, because it's got a negative exponent, it's got to switch. So those two switch. Check these two out, though. See that a to the 4th? it's got a positive exponent. It stays right where it is. It doesn't matter if it's in the numerator, the top, or the denominator, the bottom. It has a positive exponent, so it stays. However, if you have a negative exponent, it's going to flip. It's going to switch. So if it's in the denominator, it goes to the top. If it's in the top already, it goes to the denominator back. The reason that is because you're multiplying. Division is multiplication by the reciprocal. The reciprocal means you flip it over. You see? So this one goes to the top right there. So that would be a to the fifth. So that's what all this would turn out to be. Now, I would never even write this in my head. But if I did, well, here's what I'm looking at. I've got 4 on the top, 2 on the bottom. That leaves 2 more on the top than the bottom, because when you reduce, you're subtracting, right? 4 minus 2, 2. A to the ninth, because I've got 4 and 5. Do you see? I would not do this step. I do this kind of in my head. Here's what I would do. Negatives, they're both negative. That means this is going to be on the top, that's on the bottom. So that means I have 4 on top, 2 on bottom. That's 2 more on the top. See, if I have 4 on the top, 2 on the bottom, there's 2 more on the top. Whereas this, I have 4 on the top, now I have 5 more. That makes 9. That's what I would do. Let's try another one. What if we had, what if we had something like this? That's kind of tricky. Now, before you get all like panicked and think, well, man, maybe I'll just end up living on a piece of cardboard on the street because I can't do math. Maybe before you panic, check this out. You see how those two are the same? The thing inside here, this base, is now the same as what we just did, and it's to the power of negative 2. So that would be 3 squared a to the ninth to the negative 2. Now here's the deal. We know that if you have a power raised to a power, that you multiply those, right? So this would be 3 to the negative 4, a to the negative 18. Now, those are both negative exponents, so they have to get changed. You can't leave one, you don't leave a negative exponent unless you're dealing with scientific notation. So that would be your final answer right there. Okay, got time for one more. Let's do one more. Let's say you're going to do 5 to the third times a to the negative b times x to the fourth divided by, let's say, 5 to the negative 2 a to the negative b x to the 7 to the power of negative 2. Oh man, you try that one. I know it's ugly. Look, do this in like 4 steps, right? Do the 5's first, do the b's first, do the x's first, then take care of that negative exponent. There's a couple things you could do. Like for example, if this was a negative 1, let me show you. Let's say we had this whole thing again. This, and there's not like a way that's always best. Oh, well, I wrote that number wrong. There's not a way that's always best, but let's say we had this to the power of negative 1. Now I know that says, I wrote those wrong. I got myself all mixed up, but see that negative 1 right there? Negative 1 means you're going to divide. It means you're going to do the reciprocal. So this thing, the whole thing would just be flipped over. Do you see? The whole thing would be just flipped. That's supposed to be a 7. The whole thing would be flipped over like that, but yeah, either way. All right, so now you guys try this one. All right. You ready? I'm going to walk you through it. I'm going to do it step by step this time. I'm actually going to tell you what I was thinking, how I would kind of approach this. You ready? Okay, I'm going to try not to mess it up too. So check this out. You see this is 3 on the top, and you see this is negative 2, so this negative 2 is going to go to the top. So that's going to give me 5 A's, or sorry, 5 5's. Give me 5 5's. But that negative 2 means that that I'm going to be dividing. So I'm actually going to write it like this. So that gives me 5 to the 5th. Do you see? Now eventually that's going to give me 5 to the 10th down here, because you're going to multiply, you're going to get negative 10, you got to take care of that, right? Okay, now that equals 1. That's just gone. It's 1. Something divided by itself is just 1, so that's easy. I don't even have to worry about that. Now this is x cubed in the denominator. 4 on the top, 7 on the bottom, and there's 3 more on the bottom, like that. So now, here's my final answer. Do you see? Because this would be x to the negative 6th, but it would be in the denominator, so you have to fix it, move it up. Man, it's a lot of stuff. This is a pretty heavy topic. But it is something you can do. Each part is kind of little, and each little part is pretty simple. But yeah. Anyway, hope it's been helpful. You guys are killing it. Talk to you soon.